All right, so we're going to review a little bit from the stuff that we did on section 1, 2. We still have a few more things to do. We still have a few things to do on 1, 2. Gage, sit down. Sit down. No, you can do that later. You got to do that right now. No. Do you really have to do that right now? Sit. And why do you have a hoodie on? Take the hoodie off. Take the hoodie off.
Okay. You're going to unleash the monster.
Oh, my word. New year, same group. All right. So I said we were going to start with example 3. Let's do example 3. We've been talking about quadratics. Remember that word? And we're going to solve. Put a solve. We're going to solve quadratic equations. So we're going to start off with the easiest ones first. We're going to work our way up to the ones that were maybe a little bit more difficult. All right, so this is example 3, part A, and they all say to solve. And here it is. So x squared equals 5. So you're solving for x. All right, so you got to get x by itself. Some people look at it and say, well, x is by itself, but it's not because you got that squared thing right there. You remember how to get rid of that squared? You do the opposite. What's the opposite of squaring? Square root. That's right. So what I'm going to do is I'm going to square root this side and I'm going to square root this side. Remember whatever you do to the left? What's that? Pass that back. Okay? But there's one little extra thing that we can't forget to do here. It's not just positive square root of 5. Do you remember? What do we write in front of this? We put a plus or minus, right? Positive and a negative. Why do we do that? Well, I'm glad you asked, because what if you had something like this, right? So what squared is equal to 9? Well, 3 is, right? 3 squared is equal to 9. But there's another number that if you square, it's equal to 9. What is it? It's negative 3. That's right. If I take negative 3 and I square it, that's also equal to 9. So if I solve for x here, x would be plus or minus what? 3. Everybody see that? Because x could be positive 3 and x could be negative 3. We've talked about this before, but I'm just doing it again just to get the cobwebs out. All right? So you get the plus or minus. So that's your answer right there. That's all you can do with this. It's just plus or minus the square root of 5. Because the square root of 5, it doesn't come out to a nice whole number like this. So I just leave it square root of 5. Do I put it into a calculator and get some decimal number? No, I don't. This is the exact number. If I put this into a calculator, I would get some long number. It'd be 2 point something something, and it would keep on going forever. It's called an irrational number. I'm not going to write, and that would be, and if I just rounded it to like 2 places, that would be a rounded number. This is an exact answer right there. So keep it the square root of 5. Do not put it into a calculator. Everybody understand that? Okay? All right. Let's do another one. Part B. Here we go. X minus 2. That's in parentheses. That's being squared equals 16. All right. We do what we did on the last problem. First of all, we got to get x by itself. There's a couple things going on here, right? You're subtracting a 2 from it, but what else is going on? It's being squared. That's right. So what's the first thing we want to get rid of? No, we want the x to stay there. We want to get rid of the stuff that's with the x. Get rid of the squared first, okay? Because this is all in parentheses, right? Everything is being squared here. So I can't get rid of the minus 2 because that's inside of a squared. So I have to get rid of the squared first. We just did a problem. How do I get rid of a square? Square root. So I can square root this side. When you start getting problems that are a little bit longer, I'm not going to show that big old square root on the left, right? Because we know what's going to happen. That square root will cancel out with that square, correct? But I do need to put the square root on the right side and put the plus or minus. Don't forget that plus or minus. So what happens here? What happened to the square here? Canceled out, didn't it? All right, so what am I left with? X minus 2 equals. Now let's figure out what this is. What's plus or minus the square root of 16? It's not just 4. Why do we need it? I just explained it to you right here. We need the plus or minus because it's not only 3 that's being squared to give you a 9, it's also a negative 3 that's being squared to give you a 9. So you get 2 answers for this. It's not just 3. Now 3 is one of the answers, but it's also negative 3. So if I want to find out all my answers, I have to have a positive 3 and a negative 3. Same thing with this. You know square root of 16 is 4, but it's not just a 4, it's what? It's a positive 4 and it's a negative 4. Okay? Watch what I'm going to do. There's several different ways you could approach this, but I'm just going to do it like this. Plus or minus 4. You say, how in the world do I work with this? Well, first of all, one more step. One super easy step to get rid of the x. How do I get rid of the x? Plus 2. All right? Everybody see that? Plus 2, plus 2. So here's what I have. X equals plus or minus 4 and then plus 2. Again, what does plus or minus 4 mean? It means you have 2 answers. You have a positive 4 and you also what? Have a negative 4. So I'm not just going 4 plus 2 is 6, am I? No. That's part of it. So there's the positive 4, right? Remember, this is plus or minus. So there's the positive 4 plus 2, which is what? 6. But there's also what? A negative 4. So you're going to have to take that negative 4 and add it to 2 as well. Right? We add the 2 to a positive 4. We add the 2 also to a negative 4. What's negative 4 plus 2? It's negative 2. So what's my answer for x? X is equal to, we usually put the smaller one first. Like if you look in the back of the book, they'll always put the smaller one first. So let's do it that way. What would it be? Negative 2 and 6. So put a comma just to show it's both of those. If you want, you could write x equals negative 2, x equals 6. That'd be fine. All right, but this is how I would write it. Do you remember what the book does, though? They don't write x. I think they might write x equals. I'm not sure if they write x equals or not. But they don't just put negative 2 comma 6. What do they write it as? They put it in that little brace thing. Remember that? So this is what it's going to look like in the book. I don't really care if you write it with the braces or not. To me, that's just kind of extra. Yeah. This is fine. What I circled right there, I'd be perfectly fine with that. But this is what it'll look like in the book, and that's fine as well. We good? It's not so hard, is it? All right. So you'll have several problems that you have to do that kind of stuff too. Well, let's jump up and take it a step further. So that was one lesson. That was like maybe 2 lessons ago. I think this is the last lesson. Yeah, I think this is the last lesson that we did, this thing right here. And it's called Solve by Completing the Square. Do you remember that phrase? Completing the square. This is super important. Let's backtrack a little bit. Let's go back in time a little bit. I did this when I taught the lesson the last time you were here, but let's go back in time, and I want to establish, actually, let's do this. Let's do it like this. I want to establish a pattern. You might remember me doing this. Okay? And then let's write this one down. Let's write this down. And let's do one more. Again, if we're going to establish a pattern, we need several to do. All right? So I got these 4 things right here. These are all called quadratic equations because you got a squared, you got an x, and then you got a constant. It's just a regular number. Right? That's called a quadratic equation. Now, we want to see a pattern. I want to see we did something to this to get to this. Well, if all I did was take the first one, it looks like it's just the same thing. But is it the same thing on all 4 of these? No. So I can't just look at it and say, oh, that that third number is just going to be exactly what that middle one is. No, okay? But I did something. I actually did two things, 2 steps to this 4 in order to get 4. If that was my only thing, it would be hard to see. But what I want you to do is I want you to establish a pattern. What did you do to 6 in order to get to 9? We did 2 different things, okay? 2 steps. What'd you do to 8 to get to 16? What'd you do to 10 to get to 25? We did the same exact 2 steps on all 4 of these. We took that middle one, we did something to it, and then we did something else to it, all right, in order to get this last number. So what do we do, Carter?
You divide it by 2.
And?
And then,
Okay, divide this by 2, what do you get?
divide it by 2, and then it equals 2, and then you multiply by itself, right?
Okay, which means you're doing what to it when you multiply by itself? You're squaring it. Good. All right, that's the pattern. Let's see if it works for all 4 of these. If I take this middle one, divide it by 2, and then square it, do I get that third number? Sure. 4 divided by 2 is 2, and then 2 squared is 4. So it works for that one. Let's see if it works for the other 3. So what do? What's my rule? I take that middle number and do what to it? Divide it by 2, and then I do what to that? Square it. Let's see if it works. 6 divided by 2 is 3. 3 squared is 9. Yep, it works for that one too. Let's see if it works for the next one. 8 divided by 2, squared. Let's see if it works. 8 divided by 2 is 4. 4 squared is 16. Yep, that works. Do you think we've established a pattern now? Yeah, let's do it one more time just to make sure. Take half of that, 10 divided by 2, square it. What's 10 divided by 2? 5 squared is 25. Does that work? It absolutely does. So, watch this. These are all perfect squares, okay? These are all perfect squares. We've talked about perfect squares in the past. Remember something like this, like x plus 3 squared. That's a perfect square. Everybody see that? All right? So x plus a number in the parentheses squared, that's all a perfect square. So that's what's going to happen here. These are going to come out to perfect squares. But let's do one more. Let's do this. What if I had x squared plus 16x? What's that third number going to be? It's a perfect square just like the rest of them are. These aren't just random numbers, okay? I rigged this thing so it'll work. So what's this third number going to be? How did you get 64? Go ahead.
All right, so it's 16 times 8. So you 16 divided by 2.
Right.
You get 8.
Right.
And 8 squared. And 8 times 8 is 4.
That's it. And that's what it's going to be. That's going to be a perfect square. Okay? Everybody see that? Tell you what, let's do this. Let's put this in a different color. Light blue. Now watch this. Remember I said these are all perfect squares? So what is this equal to? If I was to factor this, we're getting somewhere with this, I promise, okay? We're heading somewhere with this. If I factor this, what is this factored? We've done a bunch of factoring before. Like it's x plus something times x plus something. What is it? What multiplies to be 4 and adds up to be 4? 2. Right. It's 2 and 2, right? Okay. So it's x plus 2. Instead of writing x plus 2 times x plus 2, isn't it the same as x plus 2 squared? Yeah. So this is a perfect square. What about this one right here? What's that going to be? X plus 3. Right. Now, a lot of times we'll say this. We'll say x plus 3 quantity squared. That's what a professor in college, I always remember him saying that all the time. Instead of just saying x plus 3 squared, because if I just said x plus 3 squared, that could mean that. Is that the same as this? No, because I'm only squaring the 3 here. So what do I say? I say the quantity x plus 3 squared. Or some people say x plus 3 quantity squared. You follow me on that? That means the x plus 3 is in parentheses. What's this going to be right here if I factor that? You should be getting a pattern now. Right. X plus 4 quantity, what? Squared. What's this going to be? X plus 5, what? Quantity squared. Everybody see that? Okay. This is super important. Seeing the pattern, seeing that these are perfect squares, okay, and how to figure out what that last one. Notice what this thing is called. It's called completing the square. So what did I do? I left it blank, right? And what did I do? I completed the square. I made this into a perfect square. Does that make sense? Yeah. Okay? So, with that said, I'll tell you what, let me do another one. These all worked real nice because these are all even numbers. Would you agree? Yeah. All right. But what if, so far all these are even, the number in the middle, right? This middle coefficient right here, they were all even numbers. And we're dividing by 2, so it makes it work out real nice and easy, doesn't it? Okay? Because anytime you have an even number, dividing by 2 comes out to a nice whole number. All right? And you can always square a nice whole number. But what if that wasn't an even number? What if I said complete the square? What if I said x squared plus 7x plus blank? What should go here in order to make this a perfect square? Well, what did we do? This isn't quite as easy as we did before, but we're not going to use decimals. Don't use a calculator. Okay? We're not using a calculator. We're going to use fractions. So what did we do with it? We took 7, what did we do to it? Divided it by 2. And then we took it and we did what to it? We squared it. Now, 7 over 2 doesn't come out to a nice whole number, does it? All right, because it's odd. But we can still square this. So how do we square it? What is that? What is 7 squared? 49 over what? 4. That's right. So what goes here? 49 over 4. Everybody see that? If you wanted to factor it, what would it be? You put an x, put a plus, since they're all plus here. So what goes here? Just 7? What do we do to this? What do we do to 25 to get that 5? Took square root of it. What do we do to 16 to get 4? Took the square root of it. 9 to get 3, square root. 4 to get 2, square root. So what do we do to 49 over 4 to get that number right there? Take the square root. What is it? 7 over 2. Everybody see that? All right, so this is a perfect square, and there we can write it like this. I thought you were going to have some great question for me. Go ahead. Let's do another one. What number do we want to use? Let's use an odd number. Let's not go crazy, though. Let's go 5. Let's go backwards. You do this. I'll give you a minute. I want you to complete the square, and then I want you to figure out what that perfect square is going to be. All right? Complete the square, like we did right here, and then figure out what this is going to be. So everybody do that. I'll leave this one up here so you can see. Figure out what this one is yet? Yeah. So how'd you figure out this one? Yep. 5 divided by 2, 5 over 2, and then you square it. And what does that give you? 25 over 4. That goes right here. There's a reason why we're doing this, okay? This is not just it. We're not doing all this stuff just to get here. Okay, this is to step up a little bit, okay? This is so we know how to do something later, all right? Now, what would be right here then? X plus what? 5 over 2. Here's another easy way to find this number. Did you notice that? You could take the square root of this last one, right? Or you could just do what? Something we've already done. Take that middle one, just divide it by 2. Isn't it the same thing? Yeah, because that's how we got it in the first place, right? We divided by 2, then we squared it. How do you go backwards? Well, you could take the square root of it, or you could divide it by 2. Okay? Does that make sense? All right. I think I've done enough of those. Now, what we're going to do is we're going to actually put this into practice. Now we're actually going to do a problem where we solve something by completing the square. Yes? No. He's gone. You're next. You're next. You're next. One at a time. No, nobody else is next. Class will be over by then. All right, let's do one. Let's do, I'll tell you what, I'm going to do an easier one than what they have in the book. Let's do this. We're going to actually solve for something. We're going to solve for x. You ready? That's what algebra is all about anyway, isn't it? Nope, don't want that. Don't want that. Let's do... Yeah, let's just do that. Hopefully this will work out. I'm just making this one up off the top of my head. This should be okay. What if I asked you to solve for x? Actually, no, that's not going to... I don't want that either. Let's put a 7 there. Okay, here we go. What if I asked you to solve for this? Well, first thing I would do is to see if this factors. Does this factor? If I put two sets of parentheses, does anything multiply to be 7 and add up to be 6? What? They're all pluses. They're all positives. Because 7 and 1 is my only choice, right? Is there any way 7 and 1 add up to be a 6? Not if they're both positive, no. All right, so I can't factor it. So here's what I do. Everybody watching? This is a brand new example. I didn't do this example when I taught it the other day, so I would write this down. What I'm going to do is I'm going to solve this by completing the square. I'm going to force this into being a perfect square. Okay? I'll show you how. First of all, I don't like that 7, so I'm going to move it to the other side. How do I move it to the other side? Subtract it. Okay? So I'm going to put x squared plus 6x plus. Now, I'm going to leave that blank right there. I took it from here and I moved it to the other side. So what's now on the other side? Negative 7. Okay? Everybody with me so far? Pretty easy, right? Yeah. What I'm going to do is I'm going to take this, just like we did right here. See how I put a plus blank, had a plus blank, all that stuff? This is where I'm going to put it into practice. And it'll be real practical. So what I'm going to do is I'm going to complete the square. So what's going to go in here in order to make this a perfect square? Okay, how do you know that? You take 6, well, you don't subtract. You divide by 2. You take that middle number, that middle coefficient right there, you divide by 2, and you square it. 6 divided by 2 is 3. 3 squared is 9. So I put a plus 9 there. Now, the difference between this and what we did earlier is that you have an equation now. All right? Everybody see the difference? Okay, I said Abu could go next. No, he can go. You got to go in order. So it's an equation. Can I just add something to one side? No, I can't just do that. Okay, in algebra, if I add something to one side, I got to add it to the other side. So what am I going to do over here? Plus 9. Everybody see why I did that? Okay. Now, why in the world did I make that a 9 to begin with? I made it a 9 so that I could make a nice, perfect square. Okay? Right? So we did a whole bunch of those steps. Look above this, right in your notes. So what's going to go in here? We already did this earlier. X plus what? 3. I could either take the square root of 9 to get a 3, or I could take that middle one and take half of it and I get a 3. Either way, you want to look at it. Everybody with me on that? Okay, equals, what's that? What's negative 7 plus 9? 2. Now, this is just like that first problem that I did when we started today, isn't it? So now, what do? I don't get rid of the 3 right away. What do I get rid of first? Get rid of the square. How do I get rid of the square? Well, I got a square root. That's what I was looking for. Now, I'm not going to put a big old square root on the left-hand side. It's too cumbersome, too much. But I'm just going to write x plus 3. But I know the squared cancel out, right? Because I took the square root of it. Now, what's this going to be? It's not just going to be the square root of 2. It's going to be plus or minus the square root of 2. That's really important because you're not getting all your answers if you don't put the plus or minus. With me so far? Yeah, this is all old stuff, right? Stuff we did right at the beginning of the class. One more step and we're basically done. How do I get rid of that 3? Subtract it. That's right. So x equals, subtract the 3 from both sides. This is how I'm going to write it. Watch. I'm going to put the 3 first. Okay, the minus 3 first. And then I'm going to put plus or minus the square root of 2. And that is how I'm going to write my answer. It's actually 2 answers, isn't it? It's negative 3 plus the square root of 2. And it's also what? Negative 3 minus the square root of 2. So you do get 2 answers. It kind of looks like 1, but you get that plus or minus there. That means we get 2 answers. What do you think? So that's solving by completing the square. All right? Let's do another one. That one was a little bit easier because that was an even number. Let's do one where that middle one is not an even number. This is the same exact example that I did before we had our break. This is example 4 in the book. And it says to solve. All right? So we've done this once before, but now it's all coming back to you, isn't it? All right, here it is. Almost hate to do this because you could factor this, couldn't you? And we did that last time. I'm not going to do it, but you could factor it. Because what times what is 4 and they both add up to 5? 4 and 1, right? So you could factor this, and you could solve for it very, very easily by factoring. But we're trying to learn something new today, though, okay? You can't always factor. Like in that last problem, you couldn't factor it. But on this one, you could. If it was me and all they said was to solve for it, I probably would factor it. But I'm asking you to factor it by completing the square, okay? So let's do that. So what am I going to do with that 4? That's it. Put it on the other side. So x squared plus 5x plus, I leave a blank. I actually put a blank there, okay? Put a little line so I know I got to fill it in with something. And what's on the other side? Negative 4. Easy right now, right? So far. Now I want to fill in that blank. I want to complete the square. So what do I do to fill in that blank? Yeah, take that middle one, divide it by 2, and then do what to it? Square it. And that gives me 25 over 4. I'm going to go kind of fast because I only got like 2 more minutes left. So I put a 25 over 4 right here. Now, I can't just add that to the left side. What else do I have to do? I got to add it to the right side. Okay? Now this, we did this earlier. How do I know what this is? This is a perfect square now because I made it into a perfect square. So what goes here? 5 over 2. You could either take the square root of this one or take half of the middle one. Equals. Now, this is probably the hardest part that a lot of you guys are going to encounter because you hate fractions, but it should be pretty easy. Put that over 1. What's my common denominator? I got a 1 and a 4. What's my common denominator? It's 4. I can't teach you how to add fractions. You're going to have to learn how to add fractions. So 1 times 4 is 4. So what's my numerator going to be? I multiplied 1 times 4, so multiply negative 4 times 4, which is negative 16, plus 25. So what's that? What's 25 minus 16? That would be 9. Okay? Now, we're almost done. We're getting there. Let's get rid of the square root, or get rid of the square. How do we get rid of a square root? We take the square root. So I've got x plus 5 over 2 equals plus or minus the square root of 9 over 4. Almost one more step. One more step, then we got to simplify. How do I get rid of that 5 halves? Subtract it. So x equals, now I'm going to put it out in front. Is that all right? And then plus or minus. What's this? What's the square root of 9 over 4? 3 over 2. But I'm not going to leave it like this. I left it like that before because I had a square root. Okay, but these, you can actually get an actual number for it, okay, and not a square root. So what is this? This is negative 5 halves plus 3 halves, and it's also what? Negative 5 halves minus 3 halves. Almost done. Hold on. Negative 5 plus 3 is what? Negative 2 over 2, which is negative 1. That's one of my answers. What's this? That's a negative 8 over 2, which is negative 4. That's my other answer. Those are my two answers. Okay? No homework tonight.
Yes, sir.
We'll do a new lesson tomorrow, and then I'll give you homework tomorrow.
Bye.